Hi everyone, my name is Luke Parker and this is the Presswork Engineering YouTube channel. And in this episode I'm going to be talking about methods of manufacture. Obviously we're a metal pressings company and that's what we do. We do metal press work and forming, but there are also other methods like laser cutting and spinning and punch break and fabrication that we can also talk about, as well as viable alternatives. Now, what I've got in front of me is a series of different parts, a lot of which we manufacture here and some which we don't. And what I'm going to do is basically offer options based on the criteria of the customer, so volume, specification, everything, and basically give you an insight into which way you could make your part depending on what's going to be suitable for you. So we'll jump straight in, and what I'll do is I'll pick up a couple of these parts here. So what I've got here are two flat sheets essentially. This one's obviously raised, but that doesn't pose a problem. Now, both of these are made, this one's made out of galvanised steel, which we talked about in the last video, and this one's aluminium. Now, they're both flat products, so by all means, yes, we could press both of these, no problem at all. The tooling will be relatively cheap because they're relatively flat and they're not that complex. And so by all means, yes, these could be pressed, no problem. But they could also be laser cut as well. This one in particular has been laser cut, that's where it came from. So there's no reason why you couldn't laser cut them. There are reasons why you prefer press work over laser cutting, for example. But the majority of the detail in making something like this is purely preference. So you could either laser cut it or you could stamp it. Now, one of the reasons why you may want to laser cut this is because you have a low volume. So we could quote you for this part particular, and I don't know, say several £1,000s for the tooling, and you only want 100. So obviously straight away the tooling investment would not be worth it. So what you'd say is, well, we'd get them laser cut, so we'd recommend you to a laser cutter that we know, and they could make 100 for you. Now, if these were going into, say, a vehicle or aircraft or something of higher volume, and you wanted several thousand or 100,000, then the tooling investment then is insignificant compared to the price of the unit part. So you'd invest in the tooling and go with the press metal part. In terms of finish, this is relatively burr free. Laser cutting does a great job. Has a lot of versatility. If you have a design change, then you can easily change that on the CAD, whereas if it's a press tool, obviously we've got to spend more money and modify the press tool to accommodate the design change. Press tooling for something like this would last for many millions, so once you've had it, that's it, you've got it for life. And really the same with the laser cutter, they could just keep pumping them out forever. The only difference is being the price. When we had a lot of volume, we would be, as a guess, cheaper than laser cutting on the whole, just because our process is so much quicker. We can knock these out one every second, or even quicker if you had a fast press. Whereas the laser cutting takes a little bit more time, so that's why there be various preferences. So really, I mean, like a lot of these parts, it's a volume thing. Press metal parts, stamping generally favours higher volume, purely because of the tooling investment. That's a sort of a general rule of thumb. This little part here, exactly the same. Now that could be laser cut flat and then put on a little press brake or something, and then these little ears just been folded up. That would be something that's quite easy to do. But again, with pressed metal, we could obviously stamp that out in one go and have it fall into the bin finished. So again, our part price would be cheaper, especially if, you know, this I think is a building part trade, so you probably use and throw away thousands and thousands of these. So this would be preferable for stamping and metal forming. So those really are the comparisons between laser cutting and press work. Now we use laser cutters quite a lot to make our blanks. So we have flat blanks that we load on the press. Sometimes they're odd shapes. So we ask the laser cutters to laser cut them for us, and then they ship them in, and then we form them from there. So the relationship between laser cutting and Presswork is quite knitted. We also do a product at the moment which has a laser cut finishing, so there's certain holes on various different sizes of a square part that we make, and the laser cutters have a 3D laser cutter that goes around and profiles all the holes in for us. The customer preferred that because if there's any hole changes or location changes, the tooling for that's quite expensive. So laser cutting, they just enter a different program, and the holes can be changed. So that's worth thinking about if you have a complex part, certainly with holes or shapes in that. Punches do and will break when we use them in the press, and especially if they're very small, and obviously that runs at a cost, so it's worth considering. But if you've got a flat product, basically, rule of thumb, if you've got low volume, then consider laser cutting, and by all means we'll point you in the direction of a good laser cutter. But if there's high volume and the tooling's worth investing for, then go the press method. We make a fencing bracket which we do in hundreds of thousands, and of course it's a basic bench shape, and all day long we sell those for a very low sum because it's easy for us to make. Right, we'll move on to the second crossover in manufacture, and that is circular shapes like this. Now this is sort of like a little tin. I've got a couple of other things as well. I've got a larger plate here. I've also got a cylindrical sort of domed bell shape, and another sort of bigger frying pan thing. Now we produce all these in-house. Admittedly, they are part process, they're not finished components, but principle applies. And what you've noticed with all of them is they're circular. They're all circular shapes. Now most of these parts are deep drawn, so they're drawn over a circular press tool. Various stages to get to the end result, and like I said, these are part way through, but it gives you a good idea. Now the other alternative to deep drawing or stamping of these parts is metal spinning. Metal spinning has been around for a long time, or probably as long as stamping almost, and what that involves is a lathe as such, with a flat blank of circular material held in the lathe in the chuck. The metal's then spun to a high speed, and then what they use is spoons, they call them in the train, to form the metal over a mandrel. Now this part could be done that way, probably so could this, and so could this. The benefits of metal spinning over presswork is a tooling thing. The tooling is generally less costly. They're able to make quite a lot of adjustments with spinning, and it clearly, obviously, preference is lower volume. So if you came to me and said, "Luke, I want 100 of these," we could make a press tool. Yeah, we could, but you'd look at the press tool and think, "Well, I only want 100. I'm going to bin the tooling after that. So why would I?" So you go and see a metal spinner, and they would charge you a lot less for the tooling, because they still need a mandrel to sort of mount it on. But something as standard as this, they may even have the mandrels there because it's a relatively straightforward part. And so they quote you. Now again, it's a similar situation with the laser cutting. Generally, we find that the parts are a little bit more expensive because there's more work involved. You can get CNC or computer controlled spinning machines, but a lot of it's still done manually. So there's a guy there working the spoons and working the material over a mandrel to get the finished part. And there's a lot of skill involved, just like there is with deep drawing, but once the tools are made, then it's only setting up, whereas every single part needs that skill when you're spinning. So those are the two different basic options there. So something like this they could do. Now this is quite a bit thicker material, but spinning really has quite a flexible range in terms of material thickness. There are domes that go on huge tankers, like oil tankers and things, that are spun by a machine or worked by a machine, and they can be 5, 6, 7, 8 mil thick. There's quite a huge range. So certainly very large pans, you'd need a massive press to form those. Not necessarily the tonnage you'd need, it's just the physical size. Whereas with spinning, they can handle quite large pieces that are quite thin and get a good result. Now things like jewellery, candlesticks, that type of thing, and metal lampshades and things, that's a very common industry for metal spinning. Relatively low volume, and high level of detail. And of course, while it's on the mandrel, they can also polish it and make them look very good. So spinning surf, something to consider if you've got a circular object. Obviously it doesn't work for oblong or square or funny shapes. It's obviously got to be symmetrical and circular. Low volume, again, we use spinners ourselves for circling blanks. So if we don't have them laser cut, we have blanks like I showed you in the other videos. We had circle blanks. Now they come in from a spinner who basically has a circling machine which cuts square or oblong blanks down into circles for us for the use on the press. So if you've got low volume, again, pretty much the same, like I said, as laser cutting. Low volume, high detail, then spinning may be the option for you. And again, we can point you in the direction of good spinners that we know. However, as soon as you start going up into higher volume, more detail as well, this particular part here has certain attributes on it that aren't symmetrical. So there's forms pushed into the top. They're quite high tolerance as well. Now that's not to say that metal spinners can't achieve high tolerances. They can, but with Presswork we can do it, I would say we could do it consistently to quite a high tolerance. And some of these parts we do a lot of high tolerance work with. So something like this, for example, yes, you could spin it. Again, this is part way through the process. But metal pressing with this, the tooling isn't that expensive. If I was going to make something like this, it wouldn't be that expensive, and we could make millions and millions of them off the same tooling, providing we have the right investment in the right quality of tooling, materials and coating. So those are the two alternatives that are most common to pressing. So it's never a one-stop solution to fit all. There's always alternatives and different alternatives. There's always combinations and overlaps between the two technologies. This part in particular has a little lip here, and we use almost like a spinning machine in-house, like a beading machine we call it, to put that bead on. It's a similar process. We spin the material up. It's the same sort of thing. So there's a lot of overlaps as well. One other thing as well, going back to this product, is punch presses. Now, punch presses basically look a little bit more like a laser cutter, but they have a stamping head on, and they can work flat sheet relatively easily. White goods are a very common use of punch presses. So washing machine sides and things where you've got large sheets with little holes and attributes around them, a punch press is ideal for that. Whereas our tooling would be massive to make something like that with relatively little complex parts on them. The investment in the tooling again is quite high. So you could punch press this, the machine would come down, punch all these holes out, punch the diameter out, and then have some little forming dies and punches to make these the little legs stand down. So punch pressing is another alternative as well. And as I'm thinking about it, that's about the scope of the overlap and what methods you could make things. There are obviously for one-offs and prototypes. That's always a question that we get asked a lot. Could I have one of these or one of these? Well, yeah, you can, of course, but we've got to make some form of physical tooling to make it. Otherwise, it's just the tool makers banging this over with a hammer and hoping it looks good, which of course it wouldn't. So when we talk about prototypes, there are specialist companies that do prototyping, and what you'll find is if you say, right, I want one of these, please, they would charge you maybe 200 quid maybe, I don't know. And the tooling and all the development to make the tooling and the part price would all just be thrown into one. So you would get a part. Now, obviously, with advanced metal manufacturing, additive manufacturing, there's 3D printing that comes along to offer even metal now, but predominantly plastic versions. So if you wanted to just have a mock-up and feel and try it as a fit-out, that's something we do here is print out parts in plastic, so you can try it. But if you want a real life steel part that you need for testing for heat or stress testing in the field, then a prototyping company is somebody you might want to look at. If we're in the process of obviously doing the order for a particular part, then obviously the prototypes will come off the tooling that we'll eventually use for production. But if you just want one or two, then obviously we've got prototyping companies that we work with, which we can point you in the direction of. But again, they will charge a lot more just for one part because the tooling they have to make out of something. So I hope that video was helpful. If you've got any questions over the different manufacturing, then let me know. We've got some other little parts here that I'll just show you quickly as well. This is a car bracket. Now, predominantly in the car industry, it's metal stamping, metal forming, press work because of the volumes. So this little bracket would be pressed. This little steel bar would be formed, and then they'd be welded together in an automated welding assembly, and then powder coated black. Really, that would be the only commercially viable way of doing it for the auto trade, because there's probably 100,000 at minimum of these a year, or obviously a lot more. So that would probably be your best bet. This little part here is a deep drawn flute cam with a hole in the end. Now this would be something that we deep draw over several processes. We couldn't just put this on the press and get the final part off one operation. We'd need to send this through, and I think off the top of my head this is about 5 or 6 operations. Spinning you could do, but it's quite fiddly. This one, there's lots of holes in the top, which would really suit and lend press work. So this is a commonly used press work part. This is an aerospace part made out of lightweight aluminium. For the volume, again, spinning would be quite hard with this because it's quite a shallow part and there's not a lot of work to be done. So we just put this in a press and form that over a number of operations. If you do have any parts that you're looking to make, it's a new startup maybe, or you've got some current parts that you're thinking is there an alternative method? Maybe you're having some parts spun at the moment and your volumes are increasing for whatever reason, or laser cutting for whatever reason, or you're having them pressed and you think maybe is an alternative way, or some parts of it can be changed. Then drop us a line or put a comment in the boxes below, and we'll try and answer those as much as possible. Hope you found this interesting, and stay tuned for another episode in the weeks to come. Thank you.